Welcome to the Teachers Talkin' podcast, hosted by Dustin and Ghazali Abdul Wahab. In this podcast, we discuss all things education and teaching, from innovative teaching methods to challenges to strategies and much, much more. In this discussion or roundtable-based podcast, we bring in educators from all around the world to talk about a variety of education topics so that we can support as many teachers as possible. We want this to be a place of inspiration, personal and professional development, and simply a place where we can elevate education together. Welcome to Teachers Talkin'. Hey everybody, welcome to another episode of Teachers Talkin'. I am Dustin here with my co-host Ghazali, and we are really excited to be diving into another important conversation. Like every conversation we have is really important, but today we are joined by Dr. Aditya Nagrath, who's founder of Elephant Learning Mathematics Academy. It's an ed tech platform that helps students learn years of math in just a few months with only 10 minutes a day, 3 days a week. Already something that I wish I had when I was a kid. And in this episode, it's titled Tackling Math Anxiety, How Gamification Can Change the Equation. Our guiding question is all about how can we rethink the way we teach math to reduce anxiety and build student confidence through gamified learning. So I am super excited to hear the things you have to say. But before we dive into that conversation, Aditya, can you just tell us a little bit about your background in education and what led you to start Elephant Learning?
Sure, yeah. Well, okay, I've got a PhD in math computer science. I was a GTA in mathematics for about 7 years over at the University of Denver for topics like calculus, differential equations, and linear algebra, things like that. And we started Elephant Learning in 2017 with the goal of empowering children with mathematics. The goal was, can we get them to understand the teacher in the classroom? Because what we learned was that 4 out of 5 students start kindergarten unprepared for the kindergarten curriculum. And then the other half of it became, can we work with children that have math anxiety? Because almost half of first and second graders already report math anxiety, along with half of all Americans.
All right. I think when it comes to math, right, we have to begin with this math anxiety, because for me, that's what I've got. I think math anxiety. That's why I was never good in math. But what have you noticed are the common early experiences that lead students to develop negative associations with math? Maybe you can explain what's going on in my brain.
Sure. So what we found out when we looked at the research in the US is that 4 out of 5 students start kindergarten unprepared for the kindergarten curriculum. What that means then is that there's this gap of understanding in the quantities. So if you could say a number out loud, like 1, 2, 3, 4, 5, 6, 7, that looks like counting to 10 to most parents. That's what it looked like to me before I started this project. And the challenge is that the standards define understand counting to 10 as give me 10 things. And the student's able to slide over 10 and then stop on 10. So there's like a pretty big gap there. So it's like in the second case, you really know that the student understands 10, whereas in the first case, it's like, yeah, it could just be saying. And so this exacerbates over time. So in low-income neighborhoods, you have students that are on average 3 years behind, which means you have third-grade teachers who are teaching the student how to multiply, and that student has an understanding of numbers that rivals a kindergartner or a first grader, and that's an impossible situation for both the teacher and the student. And so that's one of the things that Elephant Learning does, is that we try to identify these gaps in understanding and feed the student puzzles at the right level. The other half of the math anxiety has to do with the meaning that we're adding to the experiences that we're having. And so in our book, Treating Mathematics Anxiety, I present this model on what does a AI look like. And it's abstract enough that if you look at it, you'd see this applies to just about any learning system. It applies to the human being. So like for a human being, what this boils down to is like we have an experience, we add a meaning to it. And for math or basketball or piano or karate, it kind of comes down to, for the student, I can do this or I can't do this. And everything kind of after that's a justification for I can do this or I can't do this. So it might sound like I'm not a math person. They might have heard that from someone else. It sounds like a great justification. It's just not me. But that's the deal, right? Like as soon as I can write it off, it looks like I can't do it. I can't do it because I'm not a math person. That's it. QED, proof. So like everything after that's proof for either I can do it or I can't do it. And so like as educators, the goal is, can we keep student on the I can side of whatever that system is, that belief system?
I am definitely on the I'm not a math guy side of things. So I'm curious then, how, when we start thinking about like math learning and games, how does the gamification of math help to start shift students' mindset toward that idea that I can do it and I am a math person, instead of I can't do it and I'm not a math person?
Sure. So like one of the things that we took in the book, Treating Math Anxiety, is a basketball analogy. And what it is like a comparison between mathematics and basketball. So where they're similar is that like anyone can look and see, did the ball go in the hoop or not? And the same thing's true with math. Anyone can look and see, did the student answer correctly or not? And so like from there, they start to diverge. And one of the main places they diverge is the amount of accuracy that we expect out of the student. So like, yeah, we do expect 100% proficiency in like multiplication at some point in time. Not necessarily when the student starts, but like at some point in time, you got to be able to do this with like 95, 99% accuracy.
Mhm.
Whereas with basketball, if you're doing 80%, you're Michael Jordan. Like you're like, so that's kind of the deal, is like, if in our own mind, we can start to think about answering incorrectly more maturely, then for us, the urgency to get the student to answer correctly starts to shift. And that's already a big deal, because a lot of what the student's experiencing is inference. It's not communicated communication. It's, I'm observing emotions, I'm observing behaviors, I'm observing meaning through context. And that's what it is. So like that's why like the book talks about a lot, you actually have to believe the student can do it. You can't just say that you believe they can do it. You actually have to believe they can do it, because in that context, it has to look real.
So what would you say are the most important design elements then in your platform that help to make this work for kids?
Yeah. So like from a gamification standpoint, one of the most important things you need to have, for us, that's the elephant age. I kind of developed this based off the Wii age. I'll just be honest. I got this Wii fitness thing, and like it said I was 40 years old. And I was like, yeah, maybe I had to do something if the Nintendo thinks I'm 40 years old. You know what I mean? But it's the average age that the student outside of the system is doing the same mathematics as your student. And we calculate that based on federal standards. So we took the Common Core standards and we kind of reverse engineered what age is the student in the classroom on average when this would typically be taught in the school year. And that makes it a one number metric. So we've taken this very, very complicated bureaucracy of standards, and we've made it a one number, like 7.5. And what this allows us to do for the teacher is it allows us to average the age of the student in the classroom, and then average the elephant age of the student in the classroom, and give you, like, this is the gap. And it allows us also to graph the students based by that elephant age, so that you can quickly identify, just on average, based on where I am in the school year, which are the students that need some extra support to understand what I would normally be talking about, if that's even how your classrooms run, because like as we all know, state by state, city by city, district by district, this could change, school by school, this could change. And so like we're just trying to help out for both the teacher and the student, right? Like we want to get the student above the teacher's level of communication, but we want to get the teacher to also understand that this student might not understand multiplication, so that we don't cause that extra anxiety, because it's that talking above the student which makes them stop believing that they can do it.
So is this program for any particular age level? Does it work for any age? Do adults do it, or is it really just for kids?
We've had students of all ages. We cover from counting through algebra. Algebra is what I call the introduction to written mathematics, though the school kind of teaches it more for X. I call it the introduction to written mathematics because the ideas presented at that point in time formally are variables, functions, those types of things. And those are absolutely necessary items for you to read any STEM book, any book on finances, any book on statistics, any book. Basically, it is the third grade reading level, but for mathematics. Because if you're going to do almost anything from carpentry to whatever, yeah, guess what? You're going to be dealing with variables. You don't know how long things are. You're going to measure it. Like, what are you talking about? So, like, I don't know how much is in your bank account. It's X. This is the problem, right? And so, like, we've had students of all ages come in. We get you through algebra. I think that was your question. I'm sorry. I'm blanking.
Yeah, no,
I
yeah.
felt like it was a two-part question. I was like,
No,
it was the first part.
No, I was definitely really just curious about like if your program is for all ages or specific
Right.
ages. But then going to the idea of like the elephant age, and I just want to make sure that this is clear for anybody who doesn't know like a Nintendo Wii age. But if I'm understanding what you're saying correctly, is maybe students take like a diagnostic test or something along those lines, and what you say is what the student's actual age is 10, but where their math age is based on kind of where they're at is, you know, at age 6 or at age 13 or whatever, and that would then be their elephant age. And then you tailor, if I understand correctly, you then tailor the program to their elephant age, not necessarily their actual age. Do I have that right?
That's exactly right. That's exactly right. And what this looks like, we grab that elephant age for both the parent and student. That's like the first thing that they see as they come into the system. And we have like this classroom account from 2019, like before we even had like the classroom thing built up. So we put it in a classroom, what this would look like. And let me see if I can share screen here to show you. Does it work? Allow to share window. Looks like it's going to work. This is what the teachers, so like you can see that actually these guys stopped using it maybe 4 or 5 years ago. So this dotted yellow line, which shows the average age of that student, is way above where they should be. But if you subtract 5, like all of these students kind of started below grade level and came up to grade level. There's this student we like to talk about. His name is Royale. And the deal here is that like this particular account, this is an after school program for refugee students. So he actually came out of that placement exam at like the beginning of the curriculum. So it could be that there was language issues. It could be that he answered incorrectly on accident. But what you see is very quickly he advanced to 6 years of age and gained traction. So even from there, he caught up to where he was in grade level. These students were on average about 9 years of age. So this is a third grade student whose understanding of numbers, maybe due to language or maybe just due to accident, wasn't completely on. Very quickly got to, say, the first grade level, but then caught up to what would be grade level within, was that 4 months there?
I was to say about 3 months, it looks like. That's incredible improvement.
Yeah. And that's what we keep seeing is on average, children in our system learn this quickly. It's a combination of these activities and and the adaptive algorithms. I'm trying to figure out how to stop sharing. One of these tabs is you.
Yeah, that's really amazing. That is done in such a very fast period of time. So I'm guessing it's not just the pedagogy. I'm guessing one of the main drivers would be the gamification, the fun element. This is what makes the student want to do more math in and improve quickly. So can you tell me a bit about the creation of your program? How do you create this fun element in it? I mean, I'm sure you come from the pedagogical aspect of it, but how do you think about the fun and creative aspect? Do you have another team of people that designs the games for you?
So the fun aspect of it is to think about mathematics as a puzzle game itself. So like when you look at Sudoku, for example, this is a mathematics puzzle game. And the question is can you take addition or subtraction or multiplication or any of these ideas and make it a puzzle game? And the idea is that like, yeah, because like if you say things like give me 5 things, give me 4 more things, how many do I have now? That feels like a puzzle to a first grader. It doesn't feel like a puzzle to a 45-year-old. And that's the deal, is that like you got to empathize with the student in these things. They haven't had these experiences. We've had so many decades of experiences of give me more or take away or grouping or, etc. These ideas that would be multiplication, these ideas that would be addition occurring to us in the world. So we've seen it happen and we've had the language for it, but they haven't seen it happen. So that's kind of what the puzzle is. It's a gamification of what the idea of the mathematics is. But in doing that, because the standards define understanding multiplication, the standards define understanding multiplication as, can you see a problem in the real world? And then can you identify multiplication as the solution and the numbers to multiply, right? And so like, what we're trying to do then is we're trying to build them up to that by giving them those puzzles that would then allow them to see that, yes, for this puzzle, I should multiply, right? But by showing them, like, here's groups of things. And like, if you start to count them, if you start to add them, if you start to do that, and then we start to close the curtains. Now you have to multiply. Now you have to hold in your head, there was groups of 7 and 4 of them. So even if you're adding, but using your fingers, you're multiplying. That's what it is. You're doing it. And now you're motivated to memorize your multiplication tables because it's useful. Like instead of adding this and holding on my fingers, 7 times 4 is 28. I got it. And that's the gamification piece.
Ah, okay. Interesting. And what have you learned from designing and building and iterating this platform? Any new discoveries you have about the way that students or kids learn math?
Yeah, I mean this whole math as a language thing is the quote unquote discovery, right? Because the way we grew up learning mathematics was this is how you do it. It's something you do. And a lot of that anxiety that we face is there's a procedure to do it. And if you don't give me the procedure to do it, then how do you expect me to do it? You know what I mean? And that anxiety, that a very exact sentiment carries on into the workplace, right? Because like people expect you're going to tell me exactly how I do this job. So like it's just one of those things. Whereas like in real life, that problem solving ability, that the puzzle that we present or that the standards are asking the student to demonstrate, that's kind of the real skill. Because like if I could look out at the world and then use mathematics as a tool to solve the problems, well, now I'm doing something more than just executing the steps that a process gave me. Now I'm solving problems. Maybe I'm coming up with steps. That's what computer programming is, right? Like I got to tell the computer the steps to run. 90% of parents want their students to be able to code.
So as we start to get in, what can educators and parents do right now to start helping students who struggle with math anxiety?
The main two things that we had, say to them that you believe they can do it. I believe you can do this. You're making a commitment to them. But if they stay with you, they're implicitly making a commitment back to you. So now you're both committed to doing it. But the second piece, it's just as important, is you have to meet them at their level of understanding. So a system like ours can help you identify what that is, or most of the placement exams out there that teachers run give them a pretty good idea.
Would you say that there are or like everyday routines that can help to build student confidence in math?
Yeah, seeing this and reflecting that success in the moments of doubt. So that's what our coaches do. That's what we, again, another of the tactics that we advocate in the book. And for us, it's easy. We reflect that graph that I showed you back to them. And we say, look, this is not normal. We don't like, I got other graphs where it shows you like, here's flat lines. People's percentile never increases. They might increase in ability, but their percentile versus other students don't increase. And so it's like, this doesn't happen. This is abnormal. You're breaking the norm. You're breaking. And this type of reinforcement of you're gaining, you're going up, it just keeps the student going because they see visually the progress they're making versus like, I don't know, like this is maybe something that's missing because like you get a report card. It's not exactly like a graph. You know what I mean? Like you don't feel like there's this continuity. It's like, here's a measure. I have this problem with blood glucose, to be honest with you. So like I have, like you have to prick your finger to get the blood to get. So like as soon as I became diabetic, they had like this Abbott sensor you put in your arm and it reads the glucose continuously. I'm like, I need that. What are you talking about? Like you measure the glucose, you find out immediately like a lot of the things that you're eating are not right. That feedback system, which games provide, right? So this is like the gamification piece. Games provide that constant score. So like, am I reaching the goal, whatever the game thinks the goal should be? In our case, the goal is, do you understand the mathematics? When you pass that multiplication problem, you've demonstrated that I can see that multiplication problem. I can identify the numbers to multiply, and then I did multiply them.
Interesting.
So I'm looking at the, innovated with math teaching, math learning. So what would you see as the one change that you would want to see in the way that math is taught in schools today?
Well, I would say balance. So like as I'm speaking to administrators, district level people, as I'm speaking with math teachers out there, what you see is now like a pendulum is starting to swing with math education, right? And maybe for so long it was on this end where like you got to execute the calculations. And the reason for that actually makes sense, right? Like when you look at like our history and what human beings had to do prior to computing devices, like for example, all of the calculations required to place a human being on the moon were executed by human beings. There were not computers like proliferating NASA back then. So like this isn't like you had rooms of human beings executing calculations for engineers. That's what it was. Okay. So like they had a job for you back then. Now computers do those jobs. We don't need you to execute calculations for us. So like with Common Core, this pendulum is kind of swinging back the other way. But both things are important, and that's kind of the issue. So like I can't always depend on the machine to determine truth, especially in the AI age, right? This was the big problem with AI is like, well, we don't know. Is it going to say true things? ChatGPT told me that the Denver Broncos did not win the Super Bowl in 1997. I'm telling you what, I was there. I watched the goddamn thing. And so like This is what it is. Like, how do you know? You ask ChatGPT, it tells you something confidently. It's text. It's like if it had a tone, it'd be confident. I'll tell you what. So this is the thing. Like, how do you determine truth? Now, like, mathematics is a mechanism, at least when it comes to the philosophy of numbers or problem solving, of determining truth. You can ask ChatGPT math questions. I guarantee you, sometimes it will give you the wrong answer. And that is crazy. Think about that. Okay. So if you ask a computer a math question, you expect it to give you the right answer, but with AI, not exactly. So like, that leaves the determination of truth on the human being.
Yeah, especially with AI, when it comes to math, they are not very accurate at this moment in time. You know, like even the best one, maybe can get it right like 60, 70% of the time. Yeah, so we're not there yet.
It depends on the question you ask it.
Yeah, exactly.
Yeah. No, if you ask it a straight up math question, then in the background, it realizes to execute the calculator. So that, but if you ask it like a encoded math question, like I have, I don't know, pens. I have pens. Brown pens cost $1.11. Blue pens cost $1.55. I got 3 of these. I got 4 of those. I've seen it get it wrong. I don't know, like GPT-4. I haven't tried it yet. GPT-4o, whatever's the latest one. I haven't. Grok. I don't know, right? Like, you got to ask it. But like, this is what they keep saying is like, Apple engineers asked ChatGPT math questions and said, this isn't really intelligence. No, like, look, if you're a mathematician, you already knew this wasn't intelligence because the human being adds the meaning. And the computer, we gave it. We gave it the inputs. We gave it the outputs. I still decided the meaning, even if the training set was the internet.
Yeah, it's only recently that it knew there are, 3 R's in strawberry.
I don't know what that means, but okay. I know people on the internet, like on Facebook, they ask ChatGPT, like, what's the price of Bitcoin going to be in 2030? It's like, yeah, like, first of all, BTC is sort of BS. And so therefore, if you ask it questions about BS, its BS matches the BS that human beings would give you about the BS. And so therefore, yeah, this looks all reasonable, just as reasonable if like some rando made this up.
Yeah, I mean, that's the formula, right? BS times BS over BS. You get
Equals
BS.
BS.
You get BS. Yeah. BS squared over BS.
So, I would love to give you an opportunity of just like telling us a little bit about the book, because you've talked a lot about the platform. So tell us a little about the book.
We created this book based on, I mean, basically the philosophy. I mean, a lot of it I've kind of already said out loud, but that we were then training our coaches on, because like, as we explain in some of the stories in the book, what we kept on finding out was that like, when not our coaches at the time, just when our customer success reps followed the playbook and just said, look, I believe you can do this, children would start crying and say, you're the only person I know that actually believes this. And so that's like, wow, right? Like, there's a big demand for this. There's a lack of supply. There's a demand for this. So we started hiring ex-teachers, retired teachers, basically, that are now training teachers and training parents on treating math anxiety, and the techniques written down in our process manual to give to them for training is now this book. So like, we're giving that up. We're giving that to you, the parent, the teacher, so that you can read it, you can do what you want, but also for teachers, for schools, for districts beyond the platform, which, you know, like you saw at a glance, but like inside of there, we have conceptual mathematic teacher training at the student's level, so that if you're that 3rd grade teacher who's got that student whose understanding of math rivals the kindergartner, you're getting that conceptual math training at the student's level so that you can just catch their language up. They might not be able to do math on a clock because they didn't see it. They might not be able to do all these ancillary topics. Our product focuses on those fundamental topics that can get them to understand you and the topics that you're going to talk about in the classroom. Because if they understand those essential topics, then adding on a clock or adding with money is not a hard thing to do because they already understand addition. But without addition, that's impossible. So like this book, then also like we have a coaching program then that we sell to schools on top of the book, which actually guarantees the progress within the software system. So we will guarantee that the students will learn at least 1 year and 3 months if they use it 10 minutes 3 times a week.
Absolutely incredible results and product. So definitely 100% wish if I could go back in time and as a student and have something like that, because math was always the thing that I struggled in. And it just sounds like you are finding solutions to that. So kudos to you and your team. This has been a really interesting conversation. Like I said, we haven't talked about math on the podcast until today. And so there's a new way of thinking about math and dealing with math anxiety has been really cool to get to hear. So thank you for that. Do you have any kind of last thoughts or encouragement for educators or parents who want to help their students build confidence in math?
Well, thank you for having me on, first of all. And thank you for letting me talk about all of this, because my only mission in life is to empower children with mathematics. Like I said, I got a PhD in math. Our co-founder also had a PhD in math. And I think that the only thing that I can say is this, is that basketball analogy actually really is quite good, because there's a lot of differences and similarities, but one of the differences is this: when it comes to basketball, I could choose a different sport. When it comes to piano, I could choose a different instrument. But when it comes to mathematics and English, that's it. That's the game, especially when you're talking about elementary education. Everything after that kind of boils down to, did they make it to this level of understanding? And so we got to just keep trying. That's for both the teacher, for the parent, for the student, everyone, right? This is the game. And if we can treat it more like a game and less like your life is over if you don't learn this is the craziest part about it, right? That's the paradox, if you will, of education. Oh, but by the way, if you want to learn more about elephant learning, schools.elephantlearning.com if you're a teacher, elephantlearning.com if you're a parent, and Treating Math Anxiety is on Amazon.
Awesome. Plug it all. Well, thank you so much for being here and having this conversation with us. I think this is just another valuable episode for our listeners. So we really appreciate you. Ghazali, as always, thank you for being here, and listeners, thank you for being here as always. Do not forget to subscribe, to leave a review, to share the podcast. We are here to support educators around the world however we can. Remember, if you would like to be a guest on Teachers Talkin', you do not need to be an expert at anything, just passionate about education and ready to talk and help other teachers. So we have new episodes dropping every other Monday. Thanks again for joining us, and we will talk to you next time on Teachers Talkin'. Bye, everybody.